Good day, everyone. I've come once again to teach you today. Today, I want to teach you how to find the tan, sine, and cos of special angles in short form. When I say special angles, I'm talking about 30 degrees, 60 degrees, and what? 45 degrees. Sometimes you see how their tan, cos, and sine are what expressed in short form. You may see something like 1 over root 3 or 2 over root 3 or 1 over root 2 and so on and so forth. You'll be wondering what is happening. Follow me. Let me show you how you can derive those things so that you can easily answer them on your own. Let's go. All right. As you know, sine, sine theta, cos theta, and tan theta. All these, they are applied where you have what? Right angled triangle. We have right angled triangle like this. When you're talking about right angled triangle, you're talking about a triangle that one of its angles is equal to 90 degrees. Look at it here. We use small square to denote the right angle. So this angle, this triangle is a right angled triangle. Assuming that we have theta here, that is the angle in question. That's the angle that we are considering. The side facing the theta is what we call what? The opposite. Can you see that? Why the longest side we call it a hypotenuse, then the third side we call it a adjacent like this. Can you see that? The side facing theta is this opposite, longest side is hypotenuse, and the third side is what? Adjacent. All right, so we have something of this nature. When you're talking about angles here, we are talking about SOHCAHTOA like this. Can you see that? All right. Of course, you know, so means what? Sine theta is equals to opposite over hypotenuse. This one is the numerator, while this one is denominator. So O means opposite, while H means what? Hypotenuse like this. All right, this one means cos theta. We have C, which is cos theta, is equal to A means adjacent over hypotenuse. So we have like this, adjacent over hypotenuse. Can you see that? T means what? Tan theta, like this one. We have tan theta is equals to O, opposite over adjacent. So we have opposite over adjacent like this. Can you see that? All right, so that is it. Now, let us now derive the tan theta, cos theta, and the sine theta of these special triangles, these special angles. Right, let us have an equilateral triangle. When you have an equilateral triangle like this, you know, if you have equilateral triangle, all the sides are equal and all the angles are equal to what? 60 degrees each. So you have this place to be 60 degrees like this. You have this place to be 60 degrees, and you also have this place to be what? 60 degrees. When you sum them together, it will give you 180. Which means that sum of angles in a triangle is equals to what? 180. Assuming that this place is 2, you have this place also to be 2. You have this place to be 2. Why 2, 2, 2? Because all the sides are equal. That's why we have the name equilateral, means equal in length. Each side should be what? Equal in length. All right. So when you have something like this, we have an equilateral triangle. Then when this equilateral triangle is divided into 2 from this side, we call this one bisector. Bisector simply means a line or a point that can divide a line or an angle into 2 equal parts. So if you have this bisector, remember here I wrote 60 earlier. So by dividing it into 2 equal parts, here should be what? 30, and here should be what? 30 degrees, 30 degrees. Can you see that? So from here to here being 2, if you divide this line into 2 equal parts, that means that this place should become 1 and this place should become what? 1. I believe that is clear to you. All right, here we now have angle 30 degrees and the angle 60 degrees. So I want to pick this half of this triangle so that I will use it to express what I want to explain. All right, so if I bring out this, I will have something like this. I will have this kind of right angled triangle, like this one, of this. So as you can see, here is 30 degrees. Now look at it here. I will have 30 degrees like this. Here is what? 60 degrees, So here I will have 60 degrees. Then I have right angle here. Here I have 2. Look at it here. Here I have 1. Then this bisector, we call it root 3. So that means that here we have it to be what? Root 3. So if you are able to draw this, that means that you can easily generate the cos, sine, and tan of 30 degrees and what? 60 degrees. So we have something like this. So let us start with angle 30 degrees. We have 30 degrees like this. Can you see that? 30 degrees. All right, so if you are considering angle 30 degrees, which is this one, the side facing it is opposite. That means opposite is 1. Hypotenuse is what? Is 2. While the third side is what? The adjacent, which is root 3. So let us consider sine 30 degrees. We have sine 30 degrees like this. So sine, as we have here, means opposite over hypotenuse. Can you see it? Opposite over hypotenuse. So what is the opposite of 30 degrees? It is 1. So we have 1 here. What is the hypotenuse? We have it to be 2. So it simply means that sine 30 degrees is equal to 1 over 2. All right. If you are talking about tan 30 degrees, tan 30 degrees, look at it here. It means opposite over adjacent. Opposite over adjacent. So if you have 30 degrees, opposite is what? 1. We have 1 like this. Look at the hypotenuse. That means that this one is what? Adjacent. So it should be 1 over root 3. Can you see it? That is the value of tan 30 degrees. All right. If you are talking about cos 30 degrees, we have cos 30 degrees like this. Cos means what? Adjacent over what? Hypotenuse. All right. So looking at this 30 degrees, look at opposite. Look at hypotenuse. So look at the what? The adjacent. So adjacent over hypotenuse means what? Root 3 over hypotenuse is this. Can you see that? All right. So that will give us what? Sine 30 degrees and 30 degrees and what? Cos 30 degrees. All right. Let's talk about 60 degrees like this. If you are considering 60 degrees, look at it here. The opposite is this one. Remember, I said 30 degrees. Opposite is this one. 60 degrees. Opposite is this one. Why? Because it is this one that is facing what? The 60 degrees. All right. So let's start with our sine 60 degrees. We have sine 60 degrees like this. All right. This one, like I said earlier, sine is what? Opposite over hypotenuse. So look at opposite, which is what? Root 3 like this. And hypotenuse is what? 2. So it means that sine 60 degrees is equals to root 3 over 2. That means sine 60 degrees is equivalent to cos 30 degrees. All right, let us move on. We have cos 60 degrees like this. Cos 60 degrees, look at 60 here. Cos means what? Adjacent over hypotenuse. So if here is the opposite and here is hypotenuse, so look at the adjacent here. So adjacent over hypotenuse simply means 1 over hypotenuse is what? Is 2. Can you see that? So cos 60 degrees is equals to 1 over 2. It means that cos 60 degrees is equal to sine 30 degrees. All right, let's talk about tan. We have tan theta like this, which is tan 60 degrees like this. All right, so tan means what? Opposite over adjacent. Opposite of this is what? Is root 3. Can you see that? All right. Then adjacent is what? Is 1. So we have it over 1 like this. So anything divided by 1 is that thing. So that means that tan 60 degrees is equal to what? Root 3. Can you see that? All right. So that is it.